Today we're going to be going over CC1 4.1.3 Part 2, Review and Preview. We're going to start with problem number 39. We need to evaluate the expressions below for the given values of the variable. We need to show our work. Okay, Part A, 6 times j minus 3 for j equals 4. So anywhere I see a j, I'm going to substitute a 4. Okay, now I have to be really careful. 6j is the same thing as saying 6 times j. Remember, I can write it different ways. I use parentheses, especially when I'm substituting in a value. So 6 times 4 minus 3. We talked about this a little bit in class. I like to do algebraic expressions in like steps. So like this is step 1. Step 2 would be, well, 6 times 4 is 24. And I bring down what's left. 24 minus 3 equals 1. Okay, part B, I have 1/2 b plus 5 for b equals 14. Again, anywhere I see a b, I'm going to plug in 14. If it's next to each other like this, it's 1/2 times b. So 1/2 times 14 plus 5. Well, 1/2 times 14 is 7. It's 1/2 of 14 plus 5. 7 plus 5 is 12. Part C, 8 plus 4k, 4 times k, for k equals 3. So I'm going to rewrite it and substitute my value in at the same time. Okay, I do multiplication first. 4 times 3 is 12. I have to add my 8 in. It is 20. Problem 40. Use the hundredths grids below to help answer the following questions. Part A, I need to give 3 names for the larger shaded area. Remember that 1 column is 1/10. So if I have 1, 2, 3, 4, 5, 6 columns, it's the same thing as saying 6/10, which is also 60/100. There are 60 blocks shaded in. Okay, that's my fraction. My decimal would be 6/10, or I could write 60/100. And my percent is 60%. Okay, for part B, I'm looking at the smaller shaded area. There are 3 out of 100 shaded in. That's my fraction. My decimal, if it's 3/100, is 0 and 3/100. And my percent, if percents are fractions out of 100, my numerator is my percent, so it's 3%. Part C, what are 2 other names for 120%? Can you show 120% on a single hundreds grid? Explain your thinking. So if I have 120%, remember that percents are fractions out of 100. I could also simplify and say, well, it's 12/10. I could simplify further because I can see that 2 goes into each. So I can use that giant 1. 12 divided by 2 is 6. 10 divided by 2 is 5. Those are all equal to each other. I could write it as a decimal. I take 120%. I drop the percent sign. My decimal's here. I'm going to move my decimal 2 places to the left to get 1 and 20 hundredths. This is the same thing as 120 divided by 100. Okay, the second part of my question asks, well, can I draw it on a single hundreds grid? No, I cannot draw 120% on a single grid because it is greater than 1. Okay. Moving to problem 41. Jana is training for a triathlon and wants to eat a diet with a ratio of carbohydrates to protein to fat. That is 4 to 3 to 2. So we need to show our work each time. So first I'm going to identify which number is which. So the first number is the carbohydrate, which is the 4. The second number is going to be protein, which is the 3. And lastly, the third number is fat. It is the 2. Okay. Part A. What percent of her diet, so her whole diet, is the protein? So if I look up here, the protein is the orange. The orange number is 3. 2. I use the colon. Now it's her diet, her total diet. So her total diet would be the same as 4 plus 3 plus 2. Well, 4 plus 3 plus 2 is 9. So to find the percent, remember, I can rewrite it as a fraction and say, well, that is 3 divided by 9. I can use a calculator. Or I can do this. 9 doesn't go into 3. I have to draw a decimal point, add a 0. 9 goes into 33 times, which is 27. 30 minus 27 is 3. I add a 0. 9 goes into 33 times, which is 27. It's going to repeat. So I'm going to round it to my nearest thousandths place. And then it wants a percent. So I take my decimal point, I move it 2 places. It's 33 3/10%. Part B, what is the ratio of carbohydrates to fat? Carbohydrates was the blue. The fat was the green. I'm going to write down the carbohydrates, which is 4, 2, 2. I could write it this way. I could write it this way. Okay. I know that these are even numbers, so I'm going to divide it by 2. I can reduce just the way I do with a fraction. 4 divided by 2 is 2. 2 divided by 2 is 1. So it is a 2 to 1 ratio of carbs to fat. Okay, problem 42. What is the length of the segment connecting points -9, 3 and -9, -2? We started this last week. I'm going to find the number that's different, which are my y values. I'm going to write them down, 3 and -2. I put them in an absolute value sign and I subtract them. When I have two opposites right next to each other like this, they turn into a positive. 3 plus 2 is 5, and the absolute value of 5 is 5. Moving to problem 43, I have 7/10 plus 2/3. I am going to find a common denominator. So 10, 20, 30, 40, 50. I'm going to count by threes. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. 30s are my common, the first common multiple, so that's my least common multiple. So I'm going to rewrite my fractions as fractions out of 30. I do need to create equivalent fractions. Ten times 3 is 30. 7 times 3 is 21. 3 times 10 is 30. 2 times 10 is 20. 21 plus 20 is 41. I keep my denominator the same. If I want to practice going from a improper fraction to a mixed, I say, well, how many times does 30 go into 41? It is 1 whole time with 11 left over. Okay, part B. 0 and 9/10 minus 0 and 4/100. Remember, I need to line up my decimal points. 0 minus 4 I can't do. I have to borrow from my 9/10. 10 minus 4 is 6. 8 minus 0 is 8. Bring down my decimal point. The answer is 0 and 86/100. Part C, I'm going to take my values and I'm going to make them improper fractions first. So 3 times 4 is 12, plus 1 is 13 out of 4, plus 2 times 12 is 24, plus 11, 4 plus 1 is 5, 2 plus 1 is 3, it'd be 35/12. I need a common denominator. I'm going to count by 12s first. 12, 24, 36, 48. Then I'm going to count by 4s. 4, 8, 12, 16, 20. My least common multiple is 12. So I am going to rewrite my fractions out of 12. 35/12 is already out of 12. 13/4, use a giant 1. 4 times 3 is 12. I have to put 3 in the numerator. 13 times 3, 3 times 3 is 9. It's 39. Then I add 39 plus 35.
That would be 70.
9 plus 5 is 14. 3 plus 3 is 6, plus 1 is 7. If I had kept going with my 12s, I would have realized that 12 goes into 74 6 times. Sorry. 1, 2, 3, 4, 5, 6 times. And I would have had 2 left over. I could take a giant 1 and say, well, 2 divided by 2 is 1. 12 divided by 2 is 6. So it's 6 1/6, or 74/12. Part D, 14 times 3. 3 times 4 is 12. 3 times 1 plus 1 is 4. So 42 plus 1 is 43/3. Minus 9 times 5 is 45. Plus 1 is 46/5. Like before, I have 3 and 5. I need a common denominator. 3s, I count by 3s first. So 1, 3, 9, 12, 15, 18, 21. Then I count by 5s, 5, 10, 15, 20, 25, 30. The first one that they have in common is 15. So I rewrite my fractions out of 15. 43/3. I use a giant 1. 3 times 5 is 15. 43 times 5. 3 times 5 is 15. 4 times 5 is 20 plus 1. The other number is 46/5. I use a giant 1. Remember, my common denominator is 15. 5 times 3 is 15. 46 times 3. 3 times 6 is 18. 3 times 4 is 12, plus 1 is 3. So my 215 15ths is here. 138 15ths there. 215 minus 138. Borrow from my 10. 15 minus 8 is 7. 10 minus 3 is 7. It equals 77/15. I could change it to a fraction out of, or a mixed fraction, sorry, not a fraction out of, it's a mixed fraction. One of my numbers, it's for my last homework, never mind. I'm going to count by 15s until I get too high. So my first number is 15. Then 30, 45. 45 plus 15, 60. 60 plus 15 is 75. So It goes in 5 times with 2 left over. Those are equal to each other. As always, if you have any questions, please come and talk to me.